Welcome to demonstration video about lab activity 3. Let's start to do it. It says construct a circuit, following circuit on your breadboard. Yes. Look, this is my breadboard. I'm using a 9-volt battery for the voltage source. This is a switch. I'm using it to make on and off my voltage source easily. And let me look at the circuit again. There is a 9-volt battery. It's connected to 1 volt, and then it's divided into two. One path is touching to 2 kilo ohm resistor, and the other path is touching to 3 kilo ohm resistor. First, I will start this connection. 9 volts connection to 1 kilo ohm resistor. Follow me. Look, the red cable coming from the 9-volt battery is plus side, and the black is minus side. So minus side is connected here. So this line is completely 0 volt. Okay, I'm assuming this node as a ground. And this red one is 9 volts. I will connect this point here, and then the red line here will be 9 volts completely. Okay, now when I turn the switch on like this, okay, I have make it on now. This line is completely 9 volts. So I will connect my 1 kilo ohm resistor here. This is 1 kilo ohm resistor, but its legs are very long. Okay, I will make them shorter. So I will cut them a little bit with my cutter, okay, pliers, and then I will connect it to 9 volts like this. It's okay. As you see, I have connected it to 9 volts and a hose. Okay, so this is my switch. It's now on. Okay, now it's off. Now it's on. Okay, next what I will do is, I have connected 1 kilo ohm resistor. I will connect 2 kilo ohm and 3 kilo ohm to this node, this terminal of 1 kilo ohm. This is my 3 kilo ohm resistor. Again, it has very long legs. Okay, I will make it some shorter. I'm cutting the legs, I'm shortening them, and I inserted like this. So look here, they are touching. Okay, these 2 points are touching each other. This 1 kilo ohm is inserted into 9 volts, and here it's connected to 3 kilo ohm, and I have to connect 2 kilo ohm here too. And this is my 2 kilo ohm resistor. I'm connecting it here. Okay, I have inserted it too. 1 kilo ohm, 3 kilo ohm, and 2 kilo ohm resistors. And I know that this row is, this line is 0 volts ground. So I have to connect these terminals of 2 kilo ohm and 3 kilo ohm to ground. Let me connect. Of course, I will use cables. One cable is here. I have inserted. And the other cable is here. I have inserted. But as you see, it's a long cable. Okay, I don't need this much, so let me shorten it some. Okay, it's better to use shorter cables. Okay, my circuit is okay, and your manual says look at the results of voltages and currents of all components using Kirchhoff's laws in the lecture in your simulation. And in your simulation, there is a mistake here. Let's look at the lecture notes that we have calculated in the course. As you see, this is the same circuit. Okay, we have calculated, we have analyzed this circuit. After the analysis of this circuit, we have found that the main current is 4.09 milliamps, and the node voltage between three resistors is 4.91 volts, and the branch voltage on R1 is 4.09 volts. And it says look at your simulation. This is my simulation file. Okay, let me make it work. As you see, it says this point is 9 volts because it's connected to the voltage source. It's of course 9 volts, and the current is the same with my calculations. Okay, it's the same with the theoretical calculations, and the voltage of this point is 4.91. It's absolutely equal. Okay, it's exactly equal to the calculations, and the current in this branch is 2.45. Current on this branch is 1.64, and the main branch current is 4.09. Okay, I have calculated this in the lecture, and it's okay. It's the same. Now let's look at our manual. But first, let me stop the simulation. And it says measure the voltages and currents of all components separately. Okay, I will measure some of them. Look, this is my circuit, and this is my multimeter. Yes, this is my multimeter. Okay, I'm adjusting it to DC voltage measurement, and I'm measuring the voltage source. Oh, there is a problem. My battery is off, so I should replace my battery with a new one. Okay, it's a problem. Okay, I have replaced the battery. Now I am remeasuring the voltage source. Now it shows 9.5 volts. Okay, my battery is working now, and the total voltage across the voltage source is 9 volts. It's okay. And what's the voltage across R1? As you see, I am touching the red one to upper side. Okay, so I should read a positive voltage because the current is coming from up through down. So I have to read a positive voltage. I read 4.3. Okay, approximately 4.3. Let's look at the theoretical calculations. It says the voltage on R1 is 4.1 approximately, and I have read using multimeter 4.3. Okay, it's okay, no problem. It's because of experimental errors. Look, 4.3, and the voltage across the parallel combination, as you see, 5.2. Okay, it's very closer to the theoretical calculations. In theoretical calculations, I have found 4.9 volts. Okay, there is 0.2 volts error, but it's not important. Now I will measure the current. I will measure the main current. To do this, I'm measuring the main current. Main current is coming from the battery on the switch. It comes here, R1, it's divided into 2. So the main current is coming from here. If I open this part, I can read the main current. Look, I have opened this part and I'm measuring the current. Look, the current comes from the battery. It comes from battery. It enters the multimeter from the red probe, and it exits from the black probe. And when I touch this black probe, I will measure the current. But first, I have to adjust my multimeter to DC current. And because my resistors in kilo terms, okay, in kilo range, I will measure a milliamp current, okay. I should change this knob. This is for voltage, this is for current, okay. I have to do this. And now I can read the current. As you see, now I am reading the main branch current. There is a problem here. Okay, let me try again. Plus side is red, minus side is black. I'm touching, yes, okay. I read 4.3 milliamps. Okay, this is the main current, 4.3. Let's look at the theoretical calculations. Cannot you see? Yes, let me do it again. This is red, okay, current enters from red and it enters to multimeter. Okay, multimeter is inserted in series and it exits from the black side. When I touch the probe to the resistor, then the circuit is okay and I can see the current, 4.3 milliamps. Okay, this is the black. So this is the ammeter is inserted in series, okay. If you touch it in parallel, you cannot read the actual current, and actually you will destroy your ammeter. Let's look at the theoretical calculations. What's main current? It's 4.09, okay, so it's very closer to the measurements. And let me measure other currents. Okay, I'm completing my circuit here. Now it's okay. To measure the current of this resistor, I have to open this path, okay. I have to make it open circuit. And now there is no current on this branch. When I insert the multimeter, then there will be a current, and I will read the current on that branch. Okay, this is 2 kilo ohm resistor, and I am touching the positive side here and the negative side to the ground. And as you see, this is the current on that branch, 2.6. Let's look at the theoretical calculations. Excuse me, let's look at the simulation. 2.45. Okay, I read 2.6. It's very closer. And in that branch, simulation says 1.64 milliamps. Let's measure. Now I'm completing this branch again. Okay, I make it touch and open the other branch, and I will read it like this. Red side will be touched to the positive terminal and black side will be touched to the negative terminal, and I will read 1.7. Okay, it's very closer to 1.64. So my calculations and my simulation and my measurements are very closer and they agree with each other. Okay, So it's okay, no problem. My circuit is working, my simulation is working, my calculations are correct. Don't forget to close your multimeter and close your circuit. If you don't close your circuit, your battery will be off. Thanks.